Okay, guys, today we are going to finish up Trigonometry Part 5. We're going to be talking about evaluating trigonometric functions. And there is a repeating theme here, a recurrence that is just recurring over and over and over. And it's these two triangles here. And I'm labeling this triangle over here on the left from angle A or angle theta, okay? From angle A or angle theta, opposite is literally opposite. It's a cross. Adjacent is next to. And the hypotenuse is always across the 90. When I put this into a coordinate plane, I'm going to get a y as my opposite, the x as my adjacent, and r as my hypotenuse. And we're going to learn how to work with that very, very soon. Okay, but we got to walk before we run. That's all been done, and we've already talked about it. SOHCAHTOA. Sine equals the opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. The sine has a reciprocal function called the cosecant. And it's a reciprocal function, so it's hypotenuse over opposite. The cosine has a reciprocal function called the secant, which is hypotenuse over adjacent. And the cotangent is the reciprocal function of tangent, and it is adjacent over opposite. SOHCAHTOA, you got to memorize it, and you have to know which are the reciprocal functions for each. Okay, let's put this to work today. All right, let's get right to work. If I want to find the value of x here, guys, okay, I have to ask myself, okay, using the trigonometric functions that I have been given, okay, so I want to find the value of x. Well, all I was given was a hypotenuse, an angle which is 30, and what is the relationship of the side of x compared to that angle 30? It's adjacent. That is my adjacent. Which trigonometric function uses adjacent and hypotenuse, which is the only thing I was given? Cosine. So the cosine of 30 degrees equals adjacent over hypotenuse. Does everyone see what I just did there? That means everyone. Please talk to me. Okay, let's solve for x now. Multiply 8 to both sides. And gentlemen, you're doing trig. I promise you, you're doing trig. Now, simple calculator. Find the cosine of 30 and multiply by 8, gentlemen, please. And what do you get? Yeah, so let's go ahead and round it to the nearest hundredths. So 6.93. And that, my friends, is x. And that, my friends, is how you find missing sides using trigonometry. Yes, sir. Well, I didn't plug in whatever I wanted. I plugged in what I was given, sir. Now, whatever function I want, whatever function can handle the restrictions I was given. Could I have used sine here? No, because do I have a side for the opposite? Could I have used tangent here? No, because I don't have an opposite. What was the only thing I had? An adjacent and a hypotenuse. SOHCAHTOA. The only one that was activated was ka, because there was an adjacent and a hypotenuse. So it's not just a matter of I want to use cosine or I want to use tangent on this one, Mr. Morrow. It's not a matter of what we want, it's a matter of what we're restricted to, sir. Does that make sense?
But since you don't have the right angle that's 30 degrees, the other angle has to be 60.
I'm sorry? Yes. This angle has to be 60, yes. 100%. Okay, could I have done this? Could I have made this 4 and then made this 4 radical 3? Yes. But I'm trying to teach you how to do it with trig, Because if I have instead of 30 there a 33, the special triangle is no good for you.
No, what I'm saying is, could I use sine of 60 and then I'll have the opposite?
So he was saying, can I use sine of 60 instead of the cosine of 30? Yes, you're just adding extra work to yourself, sir. But yes, the answer is 100% yes, you may, sir. 100%. Thank you for asking, my man. Does that make sense, guys? Okay, let's move on. Let's solve triangle XYZ. By solving triangle XYZ, that means I want to find all the angles and all the sides. So we're looking for angle Y, we're looking for side Y, and we're looking for side X. Right off the bat, what's angle Y? This should be really simple. Come on, guys, how many degrees in a triangle? Okay, 180, and you have right there? 55 degrees, thank you. Okay, that's the first part. Perfect. Now, I have everything I need to use whatever trig functions I want. Let's solve for y first. Okay? Now, here's the question. Do you want to use the angle from 35 or 55? Because I don't care. Okay, 35. If we're going to use 35, what is side y in reference to 35? It's adjacent. It is not opposite. Opposite is across, guys. Opposite is across. So this is adjacent. So I have an adjacent and a hypotenuse. What trigonometric function? So the cosine of 35 equals adjacent over hypotenuse. Multiply 10 to both sides, and you're going to have y equals, it's the cosine of 35 times 10. Very good, 8.19. Let's just go to the hundreds. Oh, actually, no, yeah, we got this. We're good. Talk to me, guys. That's it. That's what I'm saying. You guys are making a mountain out of a molehill. Let's do X in red. Who do you want to use? You want to still use 35? Okay. What is the relationship now of this side to that's opposite? So I'm going to use sine. The sine of 35 degrees equals opposite over hypotenuse. Multiply 10 to both sides. X is going to equal the sine of 35 times 10, which is going to be 5.74. Yeah, let's round it to the hundreds, please. Does that make sense? Everybody. I don't want you to leave here today not knowing this. Sir.
Since we got y, we could also use tangent.
You could have used tangent if you wanted to, since you already had y, which was 8.19. My suggestion, though, is, what if you messed up accidentally, and then now this y value is wrong? Then that means that everything else is wrong. So if possible, I try to stick with the values that they gave me. I like the fact that you guys used 35. That's what they gave me. What if by chance, accidentally, we are human beings, instead of putting 55, we put 45 accidentally? And then we use 45, we would have just gotten everything wrong. So try as hard as you can to remember to use the given values first, because those are concrete and for sure. Okay, my man? Sir?
So for that, that's for angle of y, there's no...
Well, I asked for everything because I said solve this triangle. You're going to have to solve the triangle a lot. So you need to know how to find those 55 degrees, sir. Okay, it's just 180 minus the degrees they gave you. May I continue, gentlemen? Okay, thank you, gentlemen. Real life. In order to construct a bridge, and this is what they do, guys, across a river, the width of the river at that location must be determined. That's what W is right here, guys, okay? That's the width of the river. Now think about it. I'm not trying to be sarcastic, but you can't swim across the river with a measuring stick. That isn't going to work. You can't throw a rope across. That's not going to work. You can't go in a boat and measure it, because in a boat you're going up and down with the current and the waves. So that's not a straight line either. There is no way to measure this. other than using trig. You know, unless it's like a foot wide, then there's no need for a bridge, right? So suppose a stake is planted on one side of the river directly across from a second stake. These guys here, these are my stakes, okay? I put 2 stakes across the river. And from a second one opposite, stake on the opposite side. And this is a 50 meters to the left of the stake. An angle of 82 degrees is measured between the 2 stakes. Find the width of the river. This is real life, guys. I can walk this distance out. Using a special tripod, I can calculate that angle. I can do all of that. All of that by hand. Any one of us can do that. Now, how do we find W? What sides were I given in reference to the 82, guys? I was given an adjacent, which is 50, and an opposite, which is W. So you use tangent. Thank you. So the tangent of 82 equals opposite over adjacent. So 82 times tangent. Let me solve it. Sorry, I was skipping a step. Multiply 50 to both sides. So I have W equals tangent of 82 times 50, which equals 355.77 feet. Meters? Meters. My bad. I should learn how to read. My bad. Sorry. Guys, that's real life, baby. That's real life, bro. Now the engineer knows how long the bridge is. Now we can start building. Life is not just circumstance. They actually calculate this stuff out. May I continue, gentlemen? Okay, thank you, gentlemen. Now, using this leads us to what's called the angle of depression and the angle of elevation. Okay? An angle of depression and an angle of elevation. Let's talk about an angle of elevation first. Okay. This black line here, guys, this black line here is called my baseline. Okay? That's my horizontal. I want you to think of the horizontal as a straight line coming from your eyes. Okay? Or sometimes the ground. It depends on how the question goes. All right? But when you have that straight line, guys, just look ahead, all of you, forward right now. Now, put both of your hands in front of you, please. This is going to make all the world's difference, guys. Put all of your hands in front of you, please. Okay. Your left hand, keep straight. That's your baseline, okay? Now, when we look up, when you move your neck up, move up your right hand. Look up. That's an angle of elevation, guys. You have a baseline, and then you looked up. That's my angle of elevation. Okay, guys? So again, you have a baseline. So your left arm. Look up. That angle formed there, that's your angle of elevation because you went up from your baseline. Angle of depression. Same thing, my brothers. We have a baseline. The angle of depression is down here, though. Sorry. We have a baseline. Okay? And the baseline is right here. And I want an angle of depression. So I look down. Move your right hand down. That angle formed is an angle of depression. Okay? That's why I call it the line of sight. And it's not that I call it. That's what it's called. The line of sight follows your eyes, guys. The baseline stays horizontal forever. The line of sight follows your eyes. The baseline is a horizontal. You guys with me so far? Okay. So, give me 1 segundo. Okay, guys. Sorry about that. This is not example 6 at all. This is example 4. I'm sorry, I messed up the files here, but we're going to make do. Okay, the aerial run, by the way, the aerial run, it's in Snowbird, Utah. It's a ski slope. Now, you know how ski slopes are. You know, you go down, right? Okay, so the aerial run in snowboard has an angle of elevation of 20.2 degrees. Its vertical drop is 2,900 feet. Estimate the length of the run. Let me explain how we do this, okay? The ground is, well, let me not do it in blue. The ground is right here, right? So the ground is my baseline. You guys with me? Okay, this is my baseline, right? They say that it has an angle of elevation of 20.2. So look at what I'm doing, guys. Here's my arm, my baseline. I got to look up at the top of the mountain. My angle of elevation is right here, 20.2. Do you see that? That's an angle of elevation. Yes? And then they say that the vertical drop is 2,900. Well, my brothers, if I have a vertical drop and I have a horizontal baseline, I have a 90-degree, I have a right triangle now. So now I'm going to simply find the distance from here to here. That is what I'm finding. Does that make sense, guys? Okay, what was I given? What tool can I use to solve this? Opposite and a hypotenuse. So I'm going to go sine of 20.2 equals opposite over hypotenuse. Now I want you to pay attention to this. This is algebra skills here. This has nothing to do with trigonometry now. This is all algebra. Multiply x to both sides, of course. So x times the sine of 20.2 equals 2,900, of course. Divide by the sine of 20.2. Sine, let me not be messy. Sine of 20.2, cancel. So now x equals 2,900 divided by the sine of 20.2. And I'm not trying to be sarcastic, that's exactly what it is. And that equals, I got 8,398.5. Now somebody asked me, can I do it the other way? What other way is there? No, you can't use slope because you don't know what your horizontal is. Thank you for asking. Guys, there's no tricks to this. It's just use your calculator and the formulas, guys. It's not too bad. Sir. 8,398.54 feet. Yes. Okay? Okay, guys. Now, I'm going to write what's on your notes. Again, I copied this to the wrong file, so I apologize. We still got plenty of time, though. I got till 25, right? So we're golden. So it won't leave me so far. All right, let's put this to use. I put on your paper, let's practice, solve each right triangle. And for number one, I'm sorry, it's going to be sloppy. And I do apologize for those people that on the internet watching me right now. That B is called beta, by the way. And this little symbol right there up here at the top, that's called alpha. Okay? Okay, so I want to solve. So I'm looking for alpha, for A, and for B. Right off the bat, real quick, like, what's alpha, guys? 34, good job. Okay. 180 minus 90 minus 56, 34. Great job, guys. Okay. Now, how can I find A, and from what angle do you want to find A from? I don't care. These are choices you need to figure out. Okay, so let's go from 56. Who do you want to solve for first? A or B? Okay, I heard more A's. So the sine of 56 equals opposite over hypotenuse. Multiply 15 to both sides. So A equals the sine of 56 times 15. So that side is going to equal 12.44. Let's round to the hundreds, please. So that's 12.44. Does that make sense, everybody? Everybody. Okay. Now let's find B. From angle beta, what side is B? Is it the opposite or the adjacent? So who am I going to use in this case? What trig function? Cosine. Very good. So the cosine of 56 equals adjacent over hypotenuse. Multiply both sides by 15, please. And B is going to equal the cosine of 56 times 15. Which correct, guys, is 8.39. Very good. 8.39. Does that make sense? Yes, sir. Okay, the question was, once I have B, can't I use the Pythagorean theorem, Mr. Morrow? A squared plus B squared equals C squared. 100% you can. But I'm trying to teach the skill of trigonometry here today. Okay, guys, so please, again, guys, it's like the third time you guys have asked me for a shortcut. I'm not trying to not give you shortcuts on purpose. I'm trying to give you the skill of using trigonometric functions so you can always use them. If you know that you can use Pythagorean theorem, God bless you. Awesome. But I'm not teaching the Pythagorean theorem right now. I'm teaching trig. No, I know, and I'm proud of you, and I thank you. But I don't want you to think that I'm going crazy. I just want you to really practice the trig, is what I'm saying. Thank you, bro. Okay, number 2. I gave you this in number 2. Again, I apologize that it's so sloppy right now. This guy here, that's called theta, okay? Okay. So let's find theta, A, and B. Come on, what's my theta right quick? 53, thank you very much. Awesome, gentlemen. Okay, who do you want to find first, A or B? B, okay. Okay, B is what relation to 37 degrees? Opposite. So I'm going to go sine of 37 equals opposite over hypotenuse. Multiply by 33 to both sides. So you're going to get sine of 37 times 33. Excellent, guys. Excellent. 19.86. Excellent, guys. 19.86. Excellent. Okay, let's find A. What is A side in relation to angle 37? Adjacent. So which trigonometric function do I use? Cosine of 37 degrees equals adjacent over hypotenuse. Multiply 33 to both sides. So I'm going to get cosine of 37 times 33. What is it, my brothers? That's exactly what I got, 26.35. Awesome. Awesome. Be honest, guys. Is it coming together? Super easy, right? That's why I love trig, because it's easy and powerful and very useful in everyday life. May I continue, my brothers? I want to try to do the last two real quick. Okay, actually, I'm going to first go to the word problem, okay? I want to make sure you get this angle of elevation. It says, if the flagpole that a golfer aims at on a green measures 5 feet from the ground to the top of the flag, and the golfer measures a 3-degree angle from top to bottom of the pole, how far in horizontal distance is the golfer from the flag? Okay, so you've got this flag here, okay? And you know that the flag says here measures 5 feet from top of the ground to top of the flag. So from here to here, that's 5. You guys with me so far? That's the height, right? Then you got this golfer over here. I am not a good artist. You got this golfer over here, right? Okay? And this golfer, actually, I should take this guy. He's on the ground. Okay. He's measuring the angle from the ground, not his eyes, okay? He says that the golfer measures a 3-degree angle from the top of the to the bottom of the pole. So that's going to be an angle of elevation. From the ground up to the top of the pole, that's an angle of elevation. Does everyone see that? And that's going to be a 3-degree angle, okay? How far away is he from the flag? This is what I'm looking for. Now, you guys may think, bro, who cares? Have you ever heard of a guy called Tiger Woods? He cares really a lot of how far he is. How do you think that people know how far they are? There's mathematicians there doing that, okay? Yes. So, I want to find how far I am from the flag so I can know how hard to putt that golf ball. What am I going to use? What trig functions can I use? Sine? No way can I use sine. Tangent you can, though. Remember, guys, you got a horizontal and a vertical. So the tangent of 3 degrees equals opposite over adjacent. Multiply both sides by x. So x times the tangent of 3 degrees equals 5, divided by the tangent of 3 degrees. X equals 5 divided by the tangent of 3 degrees. 95.41 feet away. That's exactly correct. That makes sense, my brothers. Okay, number 3, guys, do that one on your own because we don't have time. But that's it. We have finished. Homework for part 5 is valid. Tomorrow, we're going to have a Jeopardy review game, okay? So I want you guys to study hard for that, please. Thank you. God bless you. Have a great day.